In this video, we will look into basic set notations and we will solve some basic set problems. We will begin with it. We have over here, set A contains all whole numbers less than 100 that are multiples of 8. Which of the following represents set A? Now we need to choose the correct answer. Now you can see plenty of answers over here. Let's see the first one. See, they have told multiples of 8. See, this is correct. 8, 16 and so on until 96. Yes. But look at the other options over here. They have included 0. Now, you can add 0 as a multiple of 8 because you can multiply anything with 0 and it will be 0. So in general, we add that as a multiple as well. If you want multiple of 2, you can add 2, 0, 2, 4, 6, 8 and so on. So now the more appropriate answer would be this one over here. If you look closely into all the options, this has still one more multiple. 88 is not the last multiple because they have told less than 100. 96 is the closest less than 100. So it is either 96 and 0. This is the correct answer, not anything else. So 0, 8, 16 and so on. So set A would be this. Now let's see. Set B contains all whole numbers less than 150 that are multiples of 50. Look over here, they have told less than, so 150 cannot be included. In this case, A was never a multiple of 8, so this will never be included. But here, they have just told less than. If it was less than or equal to, then it's a different case. But since it's only less than, here we are not including 150. So it'll be 0, 50, 100, and that's it. It'll be 0, 50, and 100. This is the correct answer. Consider the sets A, that is 3, 6, 9, 12, and B, 0, 3, 6, 9, 15, 18. Which of the following is true? Let's look into all the options. Set A is a subset of set B because set A contains the element 3, 6, and 9. Now first let's see whether it is a subset or no. Subset means this must be a part of the other one. Now, if you have 1, 2, and 3, and this is set A, and there is, and there is a set B. I've not written all the notations, and the set B, which contains from 1, 2, 3, 4, and 5. Now you can see the set A, 1, 2, and 3 exists in B, right? Whereas this set B is having 2 extra numbers, that's fine. But A is all included in this. So we can tell set A is a subset of set B because B also has whatever A is having. So therefore it's a subset, a small part of a set. That is it. 3, 6, 9, 12. Let's see over here. 3, 6, 9. But look, there is no 12. So this is not a subset. A is not a subset. Now set A is a subset. Set A is a subset of B. This is wrong. No, it's not. So you can see all these might be correct and this might be correct and this is wrong again. Set A is a subset because every element, no, that's wrong. We saw over here 12 is missing, right? So let's see the second option. Set A is not a subset of set B because set B does not contain 12. Yes, absolutely. If this had 12 over here, then set A would be a subset of B. So this is correct. This is not having the 12 number. Now set A is not a subset of B. Yes, it's not a subset of B. This is also correct. And now let's see the fourth one. Set A is not a subset of B because it contains 0, 15, and 18. Wait a minute. It doesn't matter what the numbers, extra numbers are there in B. It can have any number of numbers. It can have 20, 40, 50, but that doesn't make a difference. What makes a difference is this 12. So these numbers will not make a difference. So if you're telling set A is not a subset of B because of these extra numbers, that is absolutely wrong, because it is not a subset because of this 12. It does not have 12. It doesn't matter whether these are there or not there, the 0, 15 and 18. So this would be wrong over here. This is wrong. Set A is a subset is wrong, and set A is not a subset of B because set A does not contain 0. No, this is wrong. It doesn't make a difference whether it contained a 0 or no, because this 12 is not there in set B. That does not exist. So only there are two answers, this and this. So that is it. And now over here, consider the sets 2, 4, 5 and 7, and set T is 2, 4, 5, 6, 7, 8, 10. Which of the following is true? Let's see. The complement. Now, complement means the numbers which are not over here. Now, if I have to say a complement of this, S complement would mean, now it depends. S complement in T, in another set. You're comparing these two. So now we are comparing the complement of S in T. So which are the numbers that are not there in S that exists in T? What I mean is, see which are the same numbers. 2 is over here, 2 is over here. Remove it. 4, 4, 5, 5 and 7. So let me just remove these because these needs to be visible. So I have just scratched off 2, 4, 5 and 7 because they are there in S set. Now complement are the remaining numbers which were not there in S. That is 6, 8 and 10. So the complement of S in T is 6, 8, 10. Yes, this is absolutely right. Let's see the other options. The complement of S in T is 2, 3. No, it's wrong. 2, 3, 5, 7 is wrong. The complement of S and T, no. It's only this answer, 6, 8 and 10. Other two are wrong. Now the diagram below shows the values 30 to 35 and set A which contains all the odd values in this range. Enter the missing values in diagram. Let's see the diagram. Okay, over here we need to fill in the blanks. The diagram shows 30 to 35. Let's see, 30 is missing, 31, 32, 33 is missing, 34 and 35. Okay. And set A contains all the odd values. Now that means it can be 31, 35, only odd numbers. Now we have to write 30 and 33, right? Which will go over here? It's obviously the odd number, that's the 33. And 30 will be outside. So that would be 33 and 30. That's it. Now let's see over here. Consider the sets A, B and C, and then we need to find the unions and intersections. Now this intersection means it must exist, something must exist in both of these sets, A and B, right? Now this 4, is it there even in B over here? No, so this is not there. 5, no. 6, yes, 6 is a intersection. Whereas if it was union, you just write all the numbers. Don't write the repeated. Now when you're writing it be 4, 5, 6 is 2 times, just write once. Then 7, 8 and so on. That is union, you adding all, writing it all together. Whereas intersection means it's only that are there in both. So let's see over here, A intersection B would be 6. There is 8 over here. So 8, 10 and 12. So these are the 4 ones. So the intersection over here would be, let's circle them, 6, 8, 10 and 12. Now let's see the part B. Pick all the numbers that belong to A intersection B intersection C. You need to do it 2 times. Now we know the A intersection B answers over here, right? Now for these numbers you need to intersect it with C. Now compare which are common over here. So let's have these numbers. So which one over here? 0 is not there, 2 is not there, 8 is there and 10 is there. So these are the 2 answers. So if at all we didn't have A intersection B, if you had to do directly, first write down from here the A intersection B values and then find the answers with the C and get the final answer. Let's see another problem. Over here we have PQR sets. Now here pick all the numbers that belong to P union Q. P union Q. Let's see. Now it's union, right? You just have to write all the numbers. 3. Yes, 3 is correct. 5 is there. 7. And lastly it's 13. So all these. Now the next one they have told P intersection Q union S. So not writing it directly. First let's find P intersection Q. That would be P intersection Q. Which are the numbers? Only 7. That's only 7. Now you need to find the union of P intersection Q and S, union of S. So these are all numbers because 7 is there. Just write 3, 7 and 15. So these are the answers. Last one over here. Pick all the numbers that belong to P union Q intersection S. So now we have already done P union Q over here. It was 3, 5, 7 and 13. Now find the intersection with S. 3, yes, 3 is correct. 5 is not there. 7 is there. And it's 13. So only these are the two answers. So this is how we find intersections or unions. And if it's complex, do it part by part. Do the first part, then continue with the second part. And coming to the last problem, fill in the blanks to list the elements of the set T given by the property method as T V, where V is a vowel in the word modeling. Now this line means such that, or it means what exactly V, you're explaining it. Now if I write X, what is X? X is even numbers. Even numbers. Now it will be even numbers from till 5 till less than 10. So it will be 2, 4, 6, 8. That's it. So that is the thing. Now this means it's just the explanation. Now what is V over here? V is vowels in the word modeling. So now how do we write it? Now vowels are A, E, I, O, U. So just check the vowels over here. O is a vowel, E and I. So all the others are consonants. So now O, E and I are the correct answers. So this is it. So these are some basic problems in sets. It's very simple. Just look into what they are asking you, and if there are many options, go through all the options and try to eliminate the error.